All right, guys, and once again, yeah, I'm linking the video with, the PowerPoint with the video you're watching. You can even just, if you want, use it to follow along, do the split screen on Windows, and you can put the PowerPoint that I'm sending you right beside the video and just follow along if you want that way. And then when you get to the videos, you could just pause my video and play that video if you can't hear it very well. I've checked the software that I'm using, and it seems like it sounds okay on my laptop, but I don't know how it'll sound once it gets to you. So an earthquake. Most of us know what an earthquake is. We've heard about them. We experience them every once in a while. Definitely, areas where they're more active like California, but even here in West Virginia, in the Appalachian Mountains. Remember, our mountains were formed from two plates colliding, and those plates still move on occasion, and we get these small little earthquakes. We don't normally feel them or sense them very often, but occasionally we'll have one big enough to feel or sense, but it's not very often. So an earthquake is a rupture or movement of rocks along a break in the Earth's crust. It occurs at faults, also known as cracks, at the plate boundaries, and it's caused by plate movement. Again, it can be plates sliding past each other. It could be plates pushing together, or plates pulling apart can even cause this to happen. So any of our types of plate boundaries could lead to earthquakes. We normally see them with our sliding plates, with our plates when they're smashing together, but it doesn't always have to be that case. The Ring of Fire, not just a song by Johnny Cash, it's an actual thing. We find that in the Pacific Ocean. The Ring of Fire is the Pacific Plate. It contains many volcanoes and earthquakes. If you look through here, you'll see that it runs around where Australia is, up through Asia. Japan, Japan has a lot of earthquakes if you really pay close attention to the news and stuff, you hear it all the time. Up towards India, you can see up here how that would happen. Because again, and we just had that big tsunami there from an earthquake, a few years back. It goes all the way around towards Alaska, down the coast of Canada, and through North America, of course. We know with California how bad it can be. And all the way down through South America and down towards that way. And what's actually happened, the reason this is such a bad area for earthquakes, is this plate is literally going this way. And as it goes, these plates are scraping past each other. Same thing over here. And up here, around this area, this plate is going underneath this plate. So we have that convergent plate here, and right here is where the Pacific Plate goes under this region up through here. So let's show a video about earthquakes. And again, if you can't hear it, you can always click it on your own PowerPoint, or the copy I sent you, and check it out from there.
April 18, 1906, California's San Andreas Fault snaps, shaking San Francisco for nearly 60 terrifying seconds. When the trembling stops, the disaster is only beginning. Gas lines rupture, setting off massive fires. Some 700 people die. Most of the city is reduced to ruins. This trembling of the ground, caused when masses of rock suddenly shift below the Earth's surface, is called an earthquake. Hundreds of little earthquakes shake the planet every day, but most pass unnoticed. They usually occur along the boundaries of the thin plates that cover the Earth like an eggshell. Driven by the heat deep within the Earth's core, the plates grind against each other along lines called faults. When the plate's motion is blocked, stress builds up. Finally, the fault gives way. The released energy races through the Earth in the form of seismic waves. Scientists record these waves on a device called a seismograph. These zigzag lines show the strength of various seismic waves. Using the lines, scientists grade earthquakes on the Richter scale. For a quake to measure one number higher on the Richter scale, it must release about 30 times as much energy as the number below it. Every year, about 100,000 earthquakes rumble through the ground hard enough for people to feel them. Of these, only about 1,000 are strong enough to damage property. But a powerful earthquake can be devastating. On average, about 10,000 people die each year as a result of earthquakes. The greatest recorded earthquake ever to hit North America measured a massive 9.2. The tremor struck Alaska on March 28, 1964. A camera on board a ship docked in Valdez recorded the draining of the entire harbor as a chasm opened up on the sea floor. There's no stopping the surface of the earth from changing and moving, so engineers are focusing on ways to create better buildings, highways, and bridges, structures that will remain safe and stay in one piece the next time the earth begins to shake.
Okay, and again, so we see these earthquakes really bad around this ring of fire here. We have transform boundaries running through here where the plate is grinding together, and then up here, the Pacific plate is going under the other plate. All right, so with earthquakes, we get something called liquefaction / landslides. There's such a violent shaking of the earth, it causes the earth to act and move like a liquid. Sounds kind of strange that this could happen, but what can happen is when the earth starts to vibrate very bad from certain earthquakes, the earth itself can start to swallow things up. Think like quicksand, maybe you saw in movies or something like that. That's what we're talking about with liquefaction. It's kind of the same process. And of course, tsunamis, I think we're familiar with. It's an earthquake that happens under the ocean. And when it does, it causes a giant wave, and it can flood inland very rapidly. Usually with tsunamis, what happens is you'll have part of the Earth's crust under the ocean that rises up. And think about like when you're in the pool, when you take your hands and you push water and you can make a wave out of it. Well, that's exactly what happens with a tsunami. It actually takes and pushes that water as the land breaks at the earthquake boundary, and it pushes the water up. It causes that water to flow towards the land, or whatever direction, oftentimes towards the land. Let's watch this video. You can kind of check it out and see how it works.
A tragic scene. Entire cities flooded, entire towns inundated, an unending stream of floating debris. Buildings, cars, people swept away in an unstoppable wave. It's a brutal reminder. Tsunamis are dangerous and unpredictable. But what causes these giant waves, and what can be done to minimize their impact? Tsunamis can strike with little warning because they're usually triggered by a sudden displacement of ocean water, like volcanic eruptions, landslides, meteorites, or, the most common culprit, earthquakes. In the deep ocean, a typical tsunami wave is barely noticeable and poses little threat. But the waves can spread out thousands of miles, rolling across the ocean at speeds up to 600 miles per hour. As the rolling water reaches the shoreline, the wave's friction against the shallower floor slows it down and raises its height. By the time it reaches the shore, the wave can be as tall as 100 feet. Unlike ordinary waves, a tsunami wave doesn't crest and break. Instead, it moves forward like a solid wall of water that crashes over the coastline, obliterating almost everything in its path. And just when you think the danger is over, it recedes, dragging everything back to the ocean. Tsunamis have multiple waves which can continue to hit the shore for several hours, causing even more destruction. The word tsunami originates from Japan, a country that sits on a geographic location that makes it an easy target for these natural disasters. In 2011, it was struck by a tsunami that claimed nearly 16,000 lives. But the deadliest tsunami in history is believed to be the Indian Ocean tsunami of 2004. The U.S. Geological Survey estimated that tsunami released the energy equivalent of 23,000 Hiroshima-type atomic bombs. An earthquake created an estimated 600-mile rupture on the ocean floor. This caused the tsunami to form and then travel at the speed of a jetliner, reaching over 11 countries, traveling over 3,000 miles, killing more than 220,000 people. Because they can strike so quickly with such deadly force, tsunami warning centers around the globe are on constant alert, monitoring underwater earthquakes large enough to trigger massive waves. Their ultimate goal is to alert vulnerable coastlines and give residents time to seek higher ground before a tsunami hits.
All right, and excuse me, and if I go back one slide, you can see here around this ring of fire, this is the areas we worry a lot about. Of course, over through here too, we can have some issues. But even here with North America, around our coast, we have to worry about tsunamis. You know, if when this plate moves, the potential to cause a tsunami it's pretty big. It could technically happen, and so they have a lot of monitoring devices even here for us in North America.